Hi, my name is Mitchell Werden, and I will be presenting the PCI Big Beam competition for my presentation. I chose the Big Beam competition because this year I had the opportunity to lead a team through the process from start to finish. The Big Beam competition is a competition put on by the Precast Pre-Stressed Concrete Institute. This project benefits students in many ways. First, it allows students to see what goes into designing, constructing, and testing a beam. Second, it will allow students to gain real-world experience in the field and office setting. Lastly, it will help separate the participating students from others when competing for jobs after graduation. Through my experience, I would recommend this to all students that are interested in a structural engineering career. The rules of the competition are relatively easy to go through and only about 7 pages long. I encourage each team to sit down and go through these together so that everyone knows what is allowed and what will result in disqualification. To be eligible for this competition, you must be a civil engineer or construction-related major. Some of the main rules are that each team must register through the PCI website and include all participating team members' names. Each team must be sponsored by a faculty advisor as well as a local producer. This year we had the opportunity to pair with NCON. Each year the loading pattern changes and teams must design for that specific load. All teams must use commercially available material. No experimental material is allowed, and if found, will result in disqualification. Lastly, each team must include a final report that includes all pertinent information described in the report section. Now we'll be moving on to developing a design. When developing a design, you first start out by selecting a shape. This shape can be an I shape, a T shape, or just a plain rectangle. After choosing your shape, you must detail the reinforcement. For reinforcement, we chose 270 KSI strands that will be placed in the middle of the beam and a maximum distance of 5 inches from the bottom. The American Concrete Institute has limits on their depth and details them in their code. After deciding on a shape and the reinforcement, it is time to select a concrete mix. A good mix will consist of about 55% medium aggregate, which is small gravel with a diameter of about 1 inch to 1/4 of an inch. It will also contain about 45% small aggregate, which is usually sand. For the fines category, it will contain about 75% cement and 25% fly ash. Both are cementous material that will bind all the materials together, creating one homogeneous material, concrete. The overall water-cement ratio should be around 30%. This is typical in all concrete use. The type of loading will also affect your design. This year, each beam must be able to hold 30,000 pounds, but not exceed 37,000 pounds. If your beam fails outside this range, the team will be penalized for each 1,000 pound below or above the range. After completing the design, each team must come up with predictions. Each team must predict the total deflection due to the load, also what the load will be when the beam starts to crack, as well as what the ultimate strength of the beam is. After calculating each of these predictions, students are encouraged to select a software of their choice and compare their hand calculations to what the software calculated. Now into constructing the beam. Before construction can start, each team needs to prepare an elevation view as well as cross-sectional view in AutoCAD that includes all dimensions of the beam. Using these drawings, the producer that is sponsoring the team will be able to start preparing the beam's formwork. Formwork is a temporary structure that will support the wet concrete until the curing process is complete. After completing the formwork, it is time to pull reinforcing cables through. This process is very dangerous and should only be done by a licensed and trained employee. Each cable is pulled individually and has an applied force of about 5,000 pounds. These cables, when released, produce an upward deflection in the beam, allowing it to have a greater ultimate load. The last step in construction will be pouring the concrete into the formwork. After the concrete is placed, a student will use a trowel to smooth out the top of the surface of the beam. This is the finishing of the beam. The last part of the competition will be to test the beam and report the necessary values needed for judging. To test the beam will be placed under a hydraulic press that applies a constant load of about 900 to 1,000 pounds a second. To measure the necessary values, a tape measure will be placed at mid-span to measure the actual deflection due to the applied load. The report is the most important part of the competition because it is what the judges will be judging. The report consists of a title page with all the team's information, a summary of the prediction values, and testing results. The report will also include drawings of the cross-section and elevation produced earlier in the process. A recording of the test will also be used for judging, so it is necessary to videotape setting up and testing the beam. In conclusion, it is paramount that the rules and safety procedures are followed throughout the process. Doing so will result in a well-designed beam and ensure the student's safety throughout the process. Students gain valuable real-world experience in designing beams, and they learn how to create a formal report of their findings. Lastly, it is always important to have a great attention to detail throughout the process. This includes, but not limited to, double-checking everyone's calculations, having your sponsoring professor go through your calculations together, and see if you have any errors. This has been a presentation on the PCI Big Beam competition. Thank you for listening.